Hello everyone, welcome to the chapter on class 9 polynomials. So this is the second day of this particular chapter. So in the previous class we learned some basic concepts related to polynomials. For example, we learned what a polynomial is, how to identify whether a particular expression is polynomial or not, how to identify the coefficient of a particular variable in a polynomial, what is monomial, binomial, trinomial, how to identify the degree of a particular polynomial, what is linear, quadratic and cubic polynomials. So if you have not watched that video, you can watch that video first before going to this video. So in this video, we are going to do some application problems related to the concepts that we learned in the previous class. So let's start with exercise 2.1 from our NCERT book. So let's see what the first question says. The first question says that which of the following expressions are polynomial in one variable and which are not? State reasons for your answers. So some as you can see here, some expressions are given. We have to identify which of these expressions are polynomial in one variable and which are not. And we also need to give reasons for choosing our answer. Alright, so we already learned what a polynomial is. Any expression which has the power of the variables in whole numbers are known as polynomials. So let's see which expression fits this criteria. So let's start off with our question number 1. Question number 1 says that which of the following expressions are polynomials in one variable and which are not? State reasons for your answer. So what is the first expression? The first expression is, let's see, 4x square minus 3x plus 7. So we need to say whether this particular expression is a polynomial or not. Just see the power of the variables. Here the power of x is 2, the power of x is 1 here, and there is no variable. So, and since the power of the variables are in whole numbers, whole number means the numbers starting from 0, 0, 1, 2, 3 and so on. So since the power of the variables are in whole numbers, therefore this particular expression is a polynomial. So how we can write it? We can write it as follows. The above expression is a polynomial in one variable since the power of the variable, what is the name of the variable here? X, are whole numbers. Also we have how many variables here? We have one variable, therefore this is a polynomial in one variable. Let's go to our second expression. The second expression is y square plus root over 2. Now here what is the variable? The variable is y. That means we have only one variable. So one condition is fulfilled. What is the second condition? The second condition is we need to see whether the powers are in whole number or not. So here we have 2. Is 2 a whole number? Yes, 2 is a whole number. And we do not have any variable here. This is a constant term. So this particular expression is also a polynomial in one variable. Okay, so the above expression is a polynomial in one variable since the power of the variable, what is the variable here? Y, is a whole number. Okay, so let's go to our third expression. The third expression says 3 root t plus t root 2. So first condition you need to check is that how many variables are there. So as you can see here, how many variables we can identify here? We can identify only one variable, that is t in this case. So first condition is satisfied. Next we need to see whether the power of the variable t is in whole number or not. So if we look through this expression directly, it seems that the power of the variable is in whole number. But if I expand it, whenever there is a root, the power of the variable is half plus t root 2. Now is half a whole number? No, we have already discussed that whole numbers starts from 0, 1, 2, 3 like this, and there cannot be fractions in whole numbers. So here the power is half and it is not a whole number, therefore it is not a polynomial in one variable. So how do we need to write it here? We need to write it as follows: the above expression is not a polynomial, is not a polynomial in one variable since the power of the variable t is not a whole number. Why? Because the power of t is half in this case. If I can just show it to you more properly, here it is not a whole number. You need not show it like this in your exams, but here I am just giving it for more clarity. Alright, let's go to our next problem. The next problem says that number 4, it is y plus 2 by y. Now here also, if I look through it directly, it seems that it is a polynomial in one variable. But let us expand it and see. So y plus 2 to the power y can be written as 2y to the power minus y. Why? Because in our previous classes we got a rule of exponents which says that 1 by a to the power n equals to a to the power minus n. So in similar lines, here what we have, 2 to the power y, 2 to the power y we have, it can be written as 2 into 1 to the power y. That means 2 into what is the power of y? It is y 1. So if nothing is mentioned as the power, then the power is 1. So what we can write? We can write as 2 into y to the power minus 1. Now is minus 1 a whole number? No, it is not a whole number. Therefore this expression is also not a polynomial in one variable. So how we can write it? The above expression is not a polynomial since the power of y in, we can write like this, 2 to the power y is y to the is minus 1. Language can be changed a little bit, there's no issue with that. The above expression is not a polynomial since the power of y in 2 to the power y is minus 1. Alright, let's go to the next sum. It's the last sum of identifying whether something is a polynomial or not. Okay, so it is number 4, which says x to the power 10 plus y cube plus t to the power 50. Now here, is it a polynomial? Yes, because the power of the variables x, y and t are in whole numbers because the powers are 10, 3 and 50 respectively. But what is asked in the question? In the question it is asked to identify whether it is a polynomial in one variable or not. One variable is also one of the conditions. So yes, it is a polynomial, but it is not a polynomial in one variable because it contains how many variables? Because it contains 3 variables. So how to write it? We can write it as follows. The above expression is not a polynomial in one variable. This word one is very important since it contains how many variables? 3 variables. What are the variables? You can even mention it x, y and t. Alright, therefore this is not a polynomial in one variable. So I hope question number 1 is clear. Let's go to question number 2. Question number 2 asked us to write the coefficient of x square in each of the following. So let's try to find out how to find out the coefficient of x square. So in the previous class I already taught you a rule to identify the coefficient of a particular variable. So the expression here is 2 plus x square plus x. We are asked about the coefficient of what? We are asked the coefficient of x square. So what we will do in that particular term which contains x square, you will hide x square. Okay, so you will imagine that x square is not there. So if x square is not there, what do you see in this particular term? We see nothing. That means the coefficient of x square in this particular term is how much? It is 1. Alright. So the rule to find the coefficient of a particular variable is to hide that particular term whose coefficient is to be found, and after hiding it, whatever we are seeing, we will write that as the coefficient. If we do not see anything after hiding the coefficient of that particular term, then we will write the coefficient as 1. So here what will be the coefficient of x square equals to how much? It is 1. Alright. So I hope you have understood how to find out the coefficient of a particular variable. Now let's go to the second problem. Second problem asks us to find the coefficient of 2 minus x square plus x cube. Okay, we need to find the coefficient of this particular expression. So here also we need to find the coefficient of what? We need to find the coefficient of x square. So what you will do? You will hide x square with your hand. So if I hide x square here, what I am seeing here in this particular term, I am not seeing anything, but minus symbol is there. Therefore the coefficient of x square in this term is how much? It is minus 1. So if in that particular term minus symbol is there, we need to put a minus symbol before writing the coefficient. If plus is there, we need not mention plus, but if minus is there, we need to mention the minus symbol here. So how to write it here? We can write it like this. Coefficient of x square here is how much? It is minus 1. Let's go to the third problem. Third problem says pi by 2 x square plus x. Here also we need the coefficient of x square. Simple rule, just hide x square. What we are able to see? We are able to see pi by 2. So what will be the coefficient of x square? It is pi by 2. These are very easy problems. So this is the beginning of class 9. So at first we are doing easy things. Coefficient of x square is pi by 2. Alright, let's go to our next problem, which is root 2x minus 1. Now here also we need to find the coefficient of x square. Now Here one interesting thing to note is that we are asked about the coefficient of x square, but we are not able to see x square anywhere. So if that particular term is not present, whose coefficient is given to be found, then the coefficient of that particular variable or that particular term will be 0. So since x square is not here, so coefficient of x square is 0. Now why it is 0? Question may arise in your mind, because this I can write it in this manner, right? Root 2x minus 1 plus 0 x square. If we write it like that, will it make any difference to this expression? No, it will not make any difference to the expression. Therefore, if the term is not present, we write the coefficient of x square as how much? We write the coefficient of x square as 0 in this case. Alright, so with this the second question is completed. So we are done with first and second question. Now let's go to the third question. Third question asks us to give an example of a binomial. Give an example each of a binomial of degree 35 and a monomial of degree 100. So here let me remind you what is the meaning of binomial and what is the meaning of monomial. If an expression consists of two terms, then it is known as a binomial, and if the expression consists of only a single term, only one term, then it is known as a monomial. Now what is the degree? Degree is the highest power of a particular variable in a given expression. So whatever binomial we will write, the highest power should be 35. Whatever monomial we will write, the power should be 100. So let's give an example. So binomial means having how many terms? Having two terms. So at first let me give you an example of a binomial of degree 35. Binomial means two terms. So I can write like x square minus 3 y to the power 35. Why it is a binomial? Because it has two terms of degree 35. Why? Because the highest power of a variable is how much? It is 35. You can give some other examples also here, like let's say x to the power 7 plus x to the power 35 and various other examples. Just you need to keep in mind that it should contain two terms and the degree should be 35. Next we need to give an example of a monomial of degree 100. Monomial means having how many terms? Having only one term. So monomial of degree how much? Degree 100. So you write an expression which has only one term and give the power as 100. So I can write it as x to the power 100. You could have also written it as y to the power 100 and so on. But only one example is given to be written here. So you write only one example. Alright. So with this question number 3 is finished. Let's go to question number 4. Question number 4 asked us to write the degree of each of the following polynomials. What they have asked? They have asked us to write the degree of the following polynomials. Now what do we mean by degree? Degree means the highest power of a variable is known as degree. Alright. So with that concept, let us quickly write the degree of these polynomials. For the first one, we have 5x cube plus 4x square plus 7x. Now, in the first term, the power of x is 3. In the second term, the power of x is 2. In the third term, the power of x is 1. So, what is the highest power? The highest power is 3. So, the degree of the above polynomial is how much? 3. Very easy. Number 2, it is 4 minus y square. So we have only one power. So what will be the degree here? The degree is definitely 2. For the third problem, let's see, we have 5t minus root over 7. So how many variables are there? We have only one variable, so no power is mentioned. If no power is mentioned of that variable, then what is the power? The power is 1. So what will be the degree of this particular expression? The degree is nothing but 1. Now the next is number 4 is 3. Now I have mentioned about one concept in the previous class, that is of a constant polynomial. And what is the degree of a constant polynomial? The degree of a constant polynomial is always 0. Alright, so you need to remember, constant polynomials means polynomials which consists of only numbers like 4, 5, minus 8, all this. And we need to know this point. It is already mentioned in the previous video, which is the degree of a constant polynomial is 0. Now here 3 is a constant polynomial, so what will be the degree? The degree is 0. Alright, next let's go to the last question, which is some polynomials are given. We need to classify the polynomials as linear, quadratic and cubic polynomials. This also I have already discussed in the previous class. Let's discuss it in brief again here. Now when do I say that the polynomial is linear? A polynomial is linear if the degree of the polynomial is 1. How can we say that a polynomial is quadratic? If the degree of a polynomial is 2, then the polynomial is quadratic. How can we say that a polynomial is cubic? If the degree of the polynomial is 3, then the polynomial is known as a cubic polynomial. Alright, so the question says that classify the following as linear, quadratic and cubic polynomials. So we need to say whether these polynomials are linear polynomials, quadratic polynomials or cubic polynomials. So let's solve it quickly. Question number 5, number 1 is given as x square plus x. So what is the degree of this polynomial? Degree means the highest power is 2. So if the degree is 2, the polynomial is what? Quadratic. So we'll write it as quadratic polynomial. For the second one, it is x minus x cube. What is the degree? The degree is 3 because the highest power is 3. So it is a cubic polynomial. For question number 3, it is y plus y square plus 4. What is the degree here? The degree is 2. So if the degree is 2, we say the polynomial as quadratic polynomial. Let's go to question number 4. 4 we have 1 plus x. What is the degree of this polynomial? The degree of this polynomial is 1. Therefore, this particular polynomial is known as what? It is known as a linear polynomial. Let's go to question number 5. The polynomial is 3t. The degree is how much? Degree is 1. Therefore, it is a linear polynomial. Let's go to question number 6. It is r square. The degree is 2. Therefore, this polynomial is called what? It is called a quadratic polynomial. Question number 7. We have 7x cube. What is the degree? The degree is 3. Therefore, it is known as a cubic polynomial. So, again I am saying if the degree is 1, it is known as a linear polynomial. If it is 2, it is a quadratic polynomial. And if it is 3, it is known as a cubic polynomial. Okay, so that's all for the day. I hope you have understood all the questions from exercise 2.1. In the next class, I am going to discuss about a new concept known as zeros of a polynomial. Thank you very much. I hope that the session was useful. Thank you.